In this video, we are going to be looking at a proof involving parallel lines and perpendicular lines and using some of our proofs of parallel line theorems and postulates in order to work this proof out. So let's kind of walk through what we're given here. We are given this figure here, JKLM, this quadrilateral four-sided figure. We're given this transversal, right? It's a diagonal of this quadrilateral, but it's important to note that it's a transversal, right? Transversal of these two lines is also transversal of those two lines, just given by the pic. That's kind of given by the picture. We are given in the given. Let's go ahead and start writing this down as a statement here, because we know for sure that our first statement of this proof is going to be the given. So let's go ahead and try to kill two birds with one stone. So we're given that angle 1 is congruent to angle 2. So we've got angle 1 and angle 2. This since we just covered, been talking about parallel lines and transversals and all that kind of stuff, we should already kind of see a path to victory here a little bit with that statement. We're also given something else, and that is that segment LJ, so that's this segment right here, is perpendicular to segment ML. So this segment down here at the bottom, right? Very good. And those are justification, of course. Oops, I don't know why I always do that, seems like. Our justification for our step 1 of this proof is given, right? We know we're going to have that. We know we should have at least that much on a quiz, test, homework, whatever. Because we know that that's going to be the first step of this proof, regardless of anything else. Okay, so let's see if we can start looking at this. Now, we know because of definitionally, is that a word? I don't know. But we know that angle 1 and angle 2 are alternate interior angles. Now that should start to give us a clue, because we have a theorem that relates to those. In fact, because of the alternate interior angle theorem, actually the converse of the alternate interior angle theorem, we can say that LJ is excuse me, is parallel to KM. We could also, and that's looking at it kind of, this way, right? All right, there we go. That's looking at it this way. So they're alternate interior. So we can say that. We can also say JK is parallel to LM. We may, again, one of the things that I teach when we do proofs, of course, is to kind of start collecting information. So I'm going to kind of mark what I'm proving. I'm going to do it in a different color than what I have. Let's see if I use this kind of seafoam green. Is that visible on camera? Let me kind of look. No, not well enough. Let's do something else. How about a blue? That's gonna stand out and be different probably, or is this too dark? Let's take a look at it. That's fine. That's good. So we're gonna say this, and we're going to say this, right? So this is marking that these are parallel. So this is kind of how I teach you to do these proofs, right? We walk through and just start saying stuff, essentially, that we know we can say. So as our step 2, we're gonna use the same justification. So we're gonna put these both in the same step of this proof. So we're going to say that segment JL is parallel to segment KM. See, what are we proving? We're proving ML, and KM. Yeah, okay. So, yeah. So, we're going to say that JL is parallel to, what am I saying? KM, right? KM. And we're also going to throw in there, we probably don't actually need both of these, but we may as well go ahead and throw it in there that if we were doing this and submitting this as a formal proof, then we would, of course, clean it up and cut out extraneous information. But even if we were doing this like for real, then we would absolutely write these extra bits and then clean it up, probably, unless we're just amazing mathematician, right? So JK is parallel to ML. I'm going to write it ML. instead of LM, because that's the way it's written in what we're trying to prove. Okay, so we're given those two things as our second thing, and we can say this because of the converse of the alternate interior angle theorem. If you happen to have stumbled onto this video and you're not in a geometry class, then all this abbreviation might be, a whole bunch of chicken scratch. But hopefully, all right, students in geometry class will be able to understand what this is. So converse of the alternate interior angle theorem, right? Okay, so that we can say that because of that. So there we go. Now the piece of information we haven't used is this perpendicular thing, right? Right. So how could we maybe use that one? Well, we're actually given a piece of that puzzle, and we actually don't even need any more steps. We can go straight to the proof at this point, right? Because let's go ahead and write it, and then let me justify it. Let me use a different color so I can mark it clearly and cleanly, right? Let's use this orangey color, go with the proof and go with the whatever. So we're going to say, thirdly, that Km is perpendicular to ML. We actually didn't need both of these pieces, but again, it's useful to collect things and then be able to use them later. So we can say that, and we can say that because of a theorem that we've already learned, and that is, the perpendicular transversal theorem. Transversal theorem. So we're using this piece of information along with this piece of information. It says that if I have perpendicular lines, basically it says that if I have perpendicular line here that goes with a transversal, that I need to look up the right words because I'm kind of stumbling over it. I didn't put it out in front of me, and the specific words are escaping me. But basically, it says that if I have parallel lines cut by a transversal, and this is perpendicular, then we also know that this is perpendicular as well. We basically know that those things are perpendicular to each other. Pretty straightforward, pretty easy peasy, and that's it. That's it to this proof, and it's finished. Great job. See you in class. Bye-bye.